Okay, so in the last video ended, we had just decided that since f1x and f3x were equal to each other, they were but in opposite directions. f1 is going to the left and f3 is going to the right. They're just going to cancel each other out, and they're not going to have any effect on anything that's happening in this diagram. So really what we need to find are the values for f1y and f3y. They're both going down. They're both the adjacent side of that right angle triangle. And when we find them, then all three of them will add together. That's what there'll be those three forces pulling down on the spring scale. And what the spring scale is going to read will just be equal and opposite. It'll be upward, but it'll be the total of them added together. So first let's find the value for f1y and f3y. They're the adjacent side of the right angle triangle, so you have to use cosine. So cos of 30 will equal the fy's over the hypotenuse, which is 200 newtons. So Fy will equal 200 newtons cos of 30. And I just left off the 1 and the 3 because it's both of them. Cos of 30.866 times 200, so 86.6, and then double that, and you should get 173.205 or something like that. Okay, and so now the net force will simply be F1y plus F2, because it's acting completely down, plus F3y. So the 173, I should probably check that. Sorry, 200 newtons times the cos of 30. 173.205, that's pretty good. 0.205 newtons plus 200 newtons plus 173.205 newtons. Add them up, and you get a net force of 346.410 newtons. Okay, so that's what you're pulling down with, so that's what the scale would read. All right, the third one. Now the third one might seem weird, and you might think we were wickedly mean to assign it to you, but it's really not that bad if you draw it carefully. Okay, so I'm just going to do an XY axis here. Okay, because the forces are measured off the XY axis. So it says 6 forces act on a central object. Force 1 is 300 newtons acting at an angle of 30 degrees. So this is F1, and it's 300 newtons. And this is 30 degrees. Force 2 is 200 newtons acting at 60 degrees. So it's not quite as long. And it's up here. So this is F2, and it's 200 newtons. And this whole thing is 60 degrees. Force 3 is 500 newtons acting at 135. So 135 is going to be in the second quadrant, and it's going to be halfway in the second quadrant. Okay, so this is F3, and it's 500 newtons. So notice it's longer than the others. And this angle is 45, because 45 plus 90 is 135. F4 is 300 newtons acting at 210. 210, oops, maybe a little bit longer. 210, 180, this is 30 then, degrees. And this is F4. Sorry, it was off the page. And it's 300 newtons. F5 is 200 newtons acting at 240, so that was 210. So 240 is going to be down here. This angle is going to be 60 degrees. And this is F5, and it is 200 newtons. And then F6 is 100 newtons acting at 315. So 315 is in the fourth quadrant. This is 270. 315 is going to be like right here, where this is 45, and this is F6, and it's equal to 100 newtons. Now hopefully if you look at this picture you can see, oh look, this really isn't that bad. Because look, F1 and F4 are exactly opposite each other and they're exactly equal. So they cancel each other out. And then look at F2 and F5. They are exactly opposite each other and exactly equal. So they cancel each other out. And then look at F1, F3 and F6. They are exactly opposite each other, but they don't quite cancel each other out. But you can subtract them because they're opposite each other. So you don't have to break things into their components at all. You just do, 500 minus 100 is 400 newtons. And it's in the direction that the F3 was in. So at an angle of, that was 135 degrees. And that's with respect into the x-axis. So if you want WRT positive x. And you're done. See, so that wasn't that bad. Now, we didn't assign 4 and 5 on purpose because they're kind of weird. And if we were in person, we would do them together, but we're not in person, so we're just going to leave those, okay? All right. Have a good one.